Well, hello friends. Today we're going to fix a bug in the Windows server. So Jesse has been working on a Quake port for Serenity, and currently when you start it up, it very often hangs here, and the whole system hangs. And I've looked into this a little bit, but basically the issue is that the Windows server when the Windows server is talking to one of its clients, it sort of expects the client to process all of the incoming messages from the Windows server in a reasonable amount of time. Because if the client doesn't actually process an incoming message, then the Windows server will get stuck in a loop, which is what's happening here. And I'll show you what that code looks like. So this is the code in the Windows server. We have this thing called a core IPC server connection. And specifically, we are in Postmessage because we're trying to send something to a client. So we're posting a message to one of our clients. And here we try to write to the client socket, and we get this error, E again. And it just means that the client side buffer is full. In the kernel, the client's socket buffer is full, so we can't write to it right now. We have to wait and write later. But if the client never actually does anything with its input, like with that buffer, anything to drain the buffer, then we just get stuck here because we're just going in a loop. We yield, and then we go up here and try again. So I've put a fix me here at some point about how it would be better to queue these things up so that we can go back to servicing all the other clients. And that's basically what we're going to work on now, because we don't want one Windows Server client to be able to lock the Windows Server just by refusing to handle its incoming messages. So I'm thinking if we get E again, we're going to put the message on some kind of queue for the client, maybe. But let's see. So this object represents a it's an object that lives in the Windows server, and it represents a client connection. So I guess this object could have the queue, actually. So let's add it here. And wait, hold on. What kind of thing are we queuing? We are queuing server message and extra data. Right. So yeah, that's what we need to queue. Struct queued message. Okay. And then we can just put them in a queue. Call it queue. Okay, and then when we post message, we could actually, instead of doing it this way, we could always put it on the queue. So we would do something like mq append message append, something like that. And then we'll try, or like flush outgoing messages. Oh, wait, hold on. Let me do this. So if extra data is non-empty, then we want to set the message. Let's do that early on. Although that's weird, because we could get rid of the const cast here. So let's see, queued message. Okay. MQ append move queued message. All right, and then flush outgoing messages. And then we'll make this a new function instead. Flush outgoing messages. And here we'll do, maybe we'll put this in a single one actually. So let's sort the message const like buffer extra data. Okay, and then we will have a little guy here called flush outgoing messages. While the queue is not empty. Queued message mq dequeue. Flush outgoing message, queued message. I guess we don't technically want to dequeue it. Can we get something from the queue without dequeuing? Does queue not have a way to get the first thing? Because we don't want to mess up the order of the messages, so if we can't send it, we don't want to dequeue it. So I guess we can do this. T first. Const. And we don't want to move it out. We just want to... don't want to change anything. Just do that. Right. Okay. And we can maybe we'll call it head instead of first. Okay, so we'll try to flush it, and flushing should return a bool that tells us if it succeeded. Return here will say if we got a disconnection, then I would say yeah, we've succeeded because we ended here. If we get E again, let's say that we failed. And then it will stay on the queue. And if we get some other error, then let's assert so that we can print it out and figure out what to do it when we see the error. Okay, so if not flush outgoing message, no, if flush, if it fails to flush, then I guess we should break and try again later. Okay, and then otherwise MQ DQ. All right. That's good. MQ NQ is what we should be using, not append. There's no append in Q. I don't know what I was thinking. Okay, so let's just try this out to see how it feels already. Increment of read-only location. Well, see, thank you, C++, for not letting me screw that up. Obviously, I don't want to alter anything when I just retrieve the head, so we shouldn't be changing the index into the first segment. Q is, the Q class is a segmented vector, which essentially is just an optimization that means that since every time you dequeue something, we don't want to have to like shift a giant vector if you have a huge queue. So we segment the vector, the internal storage, into like multiple vectors, each maximum 1,000 elements, and that means that we never have to like shift more than 1,000 elements. Of course, we don't actually shift them; we just iterate through them. But this means that there's still an optimization, even though we don't shift things to the left, sort of. It still means that after we exhaust, we dequeue everything from a 1,000 element segment, we are able to discard that segment. So there's still value in that. Anyways. Okay, what am I messing up? In this instantiation, there is no flush outgoing message, right? Because I have to pass the message and the queued message extra data. And then here we have to actually return something. So I guess we'll say that it succeeded if we were able to send the message. So we're not going to do this in a loop here. Right? Because if we get E again, we're not going to try again. We're going to try again later. We're not going to try again now. And then I guess we're going to have to integrate this with main event loop somehow so that it will do retrying every now and then. Because we don't want to forget about the fact that we have to retry eventually. Okay, I think that's unrelated. There are a couple of like crashes on startup and like mysterious things going on lately. That's exactly why I wanted to get into this kind of bug fixing mode, because it's annoying to have random instability issues. Okay, so now it starts up and we can actually see the game starting to play a demo. It's pretty cool. That is actually Quake running on Serenity. How cool is that? It's a very good job by Jesse on the port here. Oh, the terminal dies when we kill. That's weird. Anyway, we can totally see the game start to run. So I think that's good. I know there's a similar issue probably if we make a directory and we try to run Doom in here. If there's no WAD file for Doom, then if you mouse over here, then it used to be that Doom would get very upset. Or WindowServer would get very upset because Doom is not responding. But I guess now WindowServer keeps working, it just queues everything up. So let's see how much we have in the queue. I'm trying to send WindowServer message queue size. I'm just curious if this means like that the queue is growing basically. Yeah, right. So here, now we can see that the message queue here is just growing. So at some point, we're going to have to cut him off, right? Because it's not productive to allow a process to just queue infinity messages and that it will never respond to. So we're going to have a cutoff point. I'm thinking, I don't know, how about 100 messages? If you don't get back to us within 100 messages, then that's not good. Let's see how many Quake was batching up, actually, if we just try to run that. Okay, so we made it to 13. Let's try a few times. 12. And it's some amazing fall apart there. Postmessage, flush outgoing messages. Why are you crashing, bro? Recently freed memory. Ooh, that's not good. Okay. I just spilled a bit of tea on myself. Thankfully, it was only lukewarm. Anyway. So we are in flush outgoing messages, and we have some kind of memory that is freed. Let's look at that address exactly in the Windows server. Oops. Oh, it's 80489117. It's right there, and it's right after the call to first. Okay. Oh, wait, hold on, that's inlined. So we're in head, I guess. DQ. So I take it that if we are in flush outgoing messages and we die while we're in this loop, so we call shutdown because we get disconnected, but then we'll keep going here. So actually we should probably break if we shut down, because this loop should not keep going. The whole point of this thing is for the loop to not keep going, right? I love that the kernel will tell you if a process crashed because it was like dereferencing a freed pointer. It's such a handy heuristic. Okay, do that. And then, yeah, I mean, we shouldn't kill the terminal when Quake dies, but I think that's some unrelated crap. Yeah, it's just some, I don't know why, but some weird behavior in the shell, I think. Don't have to deal with that right now. So let's add some commits. Back, add queue, head. This returns a cost T for the first. Without dequeuing it. Wait, is that how you spell dequeuing? Okay. I gotta look this up. DQ, wait. Or DQ. Yeah, there's not supposed to be an E there, although if you search for it, Then you find more hits with the E. But these are also auto-corrected results. Like, is there some way to make Google give you like literal results only? I don't want the fudged freaking fuzzy results. Anyways, yeah, my intuition was right. No E. Okay. Okay, so we'll batch these up. And then the issue now is that Postmessage. So the way that this whole system is designed, by the way, is that the server will never make any synchronous requests of the client. Only the client can make synchronous requests of the server. So it's okay that we return early from Postmessage, or not return early, but like we return without having actually sent a message, because it would be very stupid for the Windows server to do anything synchronously with one of its clients, right? So that's just designed out. Like there's no such thing as a synchronous server to client message, but there are many synchronous client to server messages. So returning from Postmessage is totally fine, but we need to, in fact, it would be okay to not do this and then to do this at a later time. And maybe that's what we should do. So flush outgoing messages, maybe he should just be called in the event loop when we get to the event loop. So we could use a notifier for this. Let's make a notifier. So ref footer C notifier. Notifier will tell us when a file descriptor becomes readable or writable. And flush notifier. So we'll make a flush notifier, and we'll do, we'll put here M notifier, socket flush notifier, sorry, is C notifier construct, and what the hell are the arguments, because I forget. File descriptor, event mask, and parent, right? So msocket file descriptor, wait, hold on. Does socket already have an internal thingy? Maybe socket has an internal mechanism for this already. Let me look at that first. I know socket has notifiers. M notifier. So that's a notifier that we use to detect when the connection has happened. And I'm ready to write. Okay, so does that get cleared at some point? Oh, wait, so here it turns off the, basically neuters the notifier, or makes it useless here. So it turns off the event mask after it's connected. So we could say that we could keep it around. And then we could make a writability notifier. So if I'm connected, then we do this. Else, if I'm ready to write, and I'm ready to write. And we'll rename this to write notifier, because it tells us that the socket is writable. And then we need a hook. Okay. Now this should allow us to do something like connection. Socket on ready to write. Flush outgoing messages. It's kind of nice. Oh, so this time we ended up accumulating quite a few more messages there. I guess it was because I was mousing over it. Yeah, look at that. Oh wait, no, it didn't happen at all. Okay, maybe sometimes it's a little bit flaky, like if I'm able to stress it or not. But yeah, there we go. So I feel like maybe we should allow more than 10 messages to queue up, or 100, but maybe like 200. I don't know. How big is the message anyway? Let's look at the API. A server message is 576 bytes. Jesus. Oh, wait, what am I trying to do? So 200 messages would be 115 kilobytes. 112. Math. Okay. That's acceptable. It's acceptable to grow that much of a queue temporarily. So I think that's okay. Actually, with the way the queue works, it's going to create a segment of 1,000 anyway, which means that we will actually have a 562 kilobyte queue. Oh, that's a little bit on the chunky side. How about we allow you to specify the segment size of a queue? Say 1,000 by default, but we'll use a smaller queue in the core IPC server. Segment size can instead be 100 or 32. I don't know, something like that. Just to, because that means that a segment of these things will be 18K, which is significantly less annoying than, because otherwise, like, every single client will end up growing the Windows Server memory usage by half a megabyte, or more than half a megabyte, just from this queue, and I think that's silly. But 18 kilobytes, I can live with that. But it's this kind of thing that, like, years from now, I'm gonna come here and find this and be like, maybe we can reduce this. You know what? I'm gonna do you a favor, future self, and lower it to 16. then maybe you'll find other stuff before you come here. It's fun to work on something where I can really feel that I'm gonna be here like years from now, and things will look different, obviously, but like I'm still gonna be doing this from years from now, because this is the kind of project that I always wanted to do, and I have no reason to ever run away from, because it covers all of my interests. So I gotta try to be nice to my future self when I'm working on this. And I hope you're nice to your future self and whatever you're working on too. Okay, so now basically the way that this works is that whenever the client socket is writable, then we try to flush messages on it. Flush message. Oh, but we also flush them here. So let's not flush them there and see if it still works. Because I'm not sure if this thing actually works. Also, I don't have to keep doing full rebuilds. I don't know why I'm doing that. If I'm only changing the Windows server, I could only rebuild the Windows server. Okay. Oh, startup crash there again. And again. Well, should probably look into that one. Okay, so this is clearly not working right. So on ready to write is not getting fired. M connected. So on ready to write. Oh, this only happens if, oh, right. So this, we have to always set this thing up. Because this is only the case where we get EM progress, which is like if you do a non-blocking connect to like a TCP server, then a non-blocking connect will just tell you, okay, fine, I started connecting. I'm not connected yet, but you know, select on the file descriptor, and then you'll find out when you get connected. This is what this is for. But down here, we synchronously connect, which will sometimes happen. For instance, if you're connecting to a local socket on the same machine, the kernel will just hook you up right away instead of it may hook you up right away, I should say. It also might not. Actually, I'm a little bit weirded out by that now that I say that, because if I connect to it, you know, shouldn't he have to accept the connection? Do we actually non-block? Oh, no, we don't. Okay, so these are blocking connects. Right, so in the case of a blocking connect, we're not going to get EM progress. That's right. So we get here because we blocked, not because it hooked it up behind the scenes immediately. I mean, it effectively did, but in a blocking fashion. So we don't progress here until the server has accepted, is my point. So here we need to set up a write notifier. So I guess we can just do this. If ready to write. If not connected. So this one's a little bit strange, because we can also do it a little bit differently. Because essentially what we want to do is we want to set up a different notifier at this point. Which is really strange, but okay. let's see how this works. Because now I'm a bit concerned that the Windows server is just going to spin now. Okay, maybe I shouldn't be doing it that way. Oh, wait, hold on. I can't be doing that because I don't have the right notifier. Okay, my bad. Because I'm concerned that the Windows server is just going to loop. Okay, that didn't go the way that I hoped either. Okay, what am I doing wrong? It fails. Mputter is not accurate, so we have a null notifier putter in common connect. Why am I completely blind? Okay, this address in what program? Taskbar? Oh, wait, hold on. I actually do have to rebuild everything. Because this stuff is linked into every program in the system. Man, I'm getting a little bit of throat pain. That's not good. But we'll power on through. Okay, so, well, we booted actually, but don't make a terrible amount of progress because why? I'm ready to write. I'll call it 1, 2, and 3. I'm just curious, are they even happening? This is probably not the best design anyway, because these sockets are always going to be able to write. And the fact that even if I fix the bugs here and make this work right, then I don't think I want this, because the socket is always going to be able to write, but I might not always have something in the queue that I want to send. So let me get rid of this, because I don't want it. ACQ. This one I like. Now, overriding the queue template parameter. Okay, so let's not do that with the socket, but let's when should we send these? I guess when we get something coming in from the client, we can try to send. Because I was thinking we should do it in the event loop, but since we've been unable to write to him, how about we just wait for him to send us something? So what would that be? Drain client? No? Oh wait, this is the wrong class. So drain client. This is where we are if we were ready to read. So if we have something to read from this right, flush outgoing. And we can also actually flush here. That's okay. So this could probably be improved, but I think this is good enough for a first version. So now we'll flush. We'll try to flush immediately when you send something, and then we'll also try to flush after we receive a message from a client. Like if we have anything to send to him, we'll try to send it then after we receive something. So the only situation here that would become bad is if a client has not been able to receive anything from us. So we have some things buffered up or queued up, and then he's not sending us anything. And but even if he takes care of his queued messages, we're not gonna actually try to send him whatever we have else in queue until he either talks to us or we try to talk to him. But I guess we will try to talk to him. Like if something doesn't seem to work, you'll mouse over it a little bit, and that will actually cause the messages to go out. So I'll probably have to revisit this, but I think I'm okay with this for now, because it makes the quick demo run. And look at it go in full screen. How cool is that? I think you can't actually start the game because it will crash. Yeah. So the port is not quite ready yet, but you're able to watch a demo, and it does look pretty cool. So it's pretty sweet. Ooh, look at that. So yeah, so I think we're gonna commit this. Oh shit, did I commit the other stuff in another commit already? Oh, I didn't mean to do that. Let's see. Okay. Right, so now we have a queue of messages, and we can structure this a little bit differently. Flush outgoing message can be turned into send outgoing message. No, not like that. I'll call it try send message. Okay, because then if try send message extra data return. Otherwise, we'll have to put it in the queue. Because then we don't need to actually interact with the queue as long as things are working nicely. And we'll actually only ever queue anything in the case where trying to send it fails. Should probably get rid of that error message. E again. Strange. Oh, wait, it's interesting that the numbers are repeating. So I guess like it's repeating because we were able to send one thing, but then it gets full again. I think that's what would be happening. Anyway, let's not print that because that's a bit annoying. What's the IPC debug, right? Okay, very cool. IPC server connections, queue up, unsendable messages. We have to put a limit to it also, but if is giving us E again, if we now queue up messages inside the core IPC server connection, and we'll retry flushing them. Next, send receive. Post receive. Right. This fixes a dead Windows server. This prevents Windows server from, or not EG, this prevents Windows server from locking, freezing up. One of its clients is not taking care of its incoming messages. And then let's put a limit on this. So in Postmessage, if MQ size, let's start with 10 just to see how that works. So shutdown. I'm cutting you off. Okay, we'll see how that goes. Because that's all it takes, right? Just call shutdown? Yeah. Because calling shutdown will basically, it will disconnect the client. So you should cut us off. I'm cutting you off. Yeah, that's good. Okay. So let's put some little thing next to this guy, like a static const max queue size is 200. Max queued messages. Yeah, that's good enough. It has too many queued messages already. Disconnecting him. It. Gotta mind your pronouns, brah. I keep blanking out, not remembering what program I was supposed to run. All right, well, good. Okay, I think that's awesome. So put a cap limit on how many messages, unsent messages, IPC server will keeps queues. It's 200, right? So this patch adds a limit of 200 unsent messages per client. If a client does not handle its incoming messages and we manage to queue up 200 messages for it, we'll now disconnect that client. Okay, I like it. Okay, so I think we're good here. Let's just see Quake one more time because it's cool. Probably I'm gonna make some more video about Quake later on as the port improves and you're able to play the game and so on. But it's awesome just being able to see the demo. So I think this is going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out, and yeah, it's we're in bug fixing mode now, more or less, doing different types of bugs, but definitely trying to improve the stability and you know, baseline performance of the system so that it gets nicer to use, nicer to work on, develop for, and so on. Yeah, so I think it's a good thing to be doing. Anyways, thank you so much for visiting and hanging out while I work on this, and for coming back. You know, it's always nice to have you guys here. I don't know what to say, so have a great day, and I will see you next time. Bye.